Hello. Welcome to my channel. In this video we are going to prove the exterior angle theorem in the strong form. This is also known as high school exterior angle theorem. This result depends upon the parallel postulate. Unlike the weak form of the theorem, the latter is known also as Euclid's exterior angle theorem, and we'll see it in details in another video. For each vertex of the triangle, the exterior angle is the angle between a side of the triangle and the adjacent extended side. Delta is the exterior angle in this case. However, for a given internal angle of a triangle, we can construct the exterior angle in two different ways, as shown in the figure. We know that the sum of the interior angles of a triangle is equal to 180 degrees or pi in radians. This is a consequence of the parallel postulate, so we are using it to prove the theorem. Eventually we know that gamma and delta are supplementary angles. With simple calculations we obtain the statement of the theorem. We have proven that the size of an exterior angle in a triangle is equal to the sum of the values of the two non-adjacent interior angles. In the last line, with simple calculations, we achieve another result. The value of the exterior angle is greater than the value of each of the other two non-adjacent angles. This achievement can be obtained without using the parallel postulate, so it is a significant one. I'll show you how to do it in another video. We draw the exterior angle corresponding to each interior angle. Sideways we have the equations referring to each of the three angles of the triangle. The angles in this new figure are also exterior angles, obtained by extending the other side at the vertex. Of course the equations remain still valid. Well, this video is over. If you like my videos, you can subscribe to the channel. See you soon with another video. Bye.